Hello everyone, welcome to the class. So I hope that everyone is fine and in good health. So we have started this topic of software testing from software engineering, and this is the part 2. I hope you all have seen video 1, that is part 1, where we have discussed the important basics of software testing. And if you haven't watched the video now, I'll be sharing the link in the description. Please watch that video first before moving on towards this video. And this is the Telegram group, as you all can see, t.me/netreadigimento. Join this Telegram group so that you can be updated about the class timings and further informations as well. So this is the mail ID admin@gatelectures.com, where you can ask queries, where you can mail your queries, or you can also call or send your WhatsApp messages on these two numbers, 982187610 or 982187610. So this is the website digimento.com. You can see this is the page when you will search for UGC net. There are three courses available right now. First, the you can buy these courses, but they are not live classes, they are the recorded sessions. Okay, so you can go for 6 months, 12 months and 3 months, and you can always use this code welcome 40 to get 40% off, and then you can buy this course. Since abhi tak there is no uh, notification about the exam, so we can hope for that the exam will be somewhere around July, and this is also not sure, this is just an estimation. So for this you can go for the 6 months course. Yes everyone, and if you are interested in live classes, so please do inform on these two numbers about your queries. If you are interested in live classes, then you can just call on these two numbers and get the required information about that. Plus there are also test series, so if you think that you have already prepared enough and now you want to go for test, there are mini test series and there are mega test series. Okay, you can go for any of the test series whichever you feel like. I think in mini test series there are around 30 tests, and in mega test series there are around 50 to 60 tests, so you can go for them. The best thing about the test series is that the questions are subject wise, so if you want to practice the concepts subject wise, then you can definitely go for these series. Okay, and again you can use the code welcome 40 and you will get 40% off on that also. Plus there are other courses available, like if you're preparing for electronic science, there is this course. If you're preparing for RRB, then this is the course. For machine learning, for ISRO, for DSSB, NVS, KVS, PGT, TGT. So if you're preparing for any exam, you can look for this website and you will definitely find the courses that are required for you. If you're preparing for GATE also, then also there are courses available. You can look for those classes as well. And again, if any query, you can also call these numbers. Plus you have the Telegram group. You can also if you have any query related to your subject or related to your course or related to your topic, then you can always message me on Telegram and I'll be there happy to help. This is the Android app. As you all know, you can install this Android app as well, and on this Android app you can get all the notifications. You can install it and you can get all the courses access. You can access the courses via this education app, that is Digimento Education. So in the previous class we have seen these few topics. As you all know, we have done, if I talk with respect to this, we've done verification, validation, we have done error, fault, bug and failure. We have done unit and integration testing. So I'm just marking all the things that we have done. Yes, I hope. Please, again I'm seeing this is part 2. Okay, in today's class we are discussing part 2. So part 1, the link will be in description. You can watch that part 1 first. Please watch part 1 first and then you can come back again to part 2, because part 2 you can only understand once you understand the basic concept of software testing. Okay, now we have roughly discussed white box and black box. We have not discussed these two box testing in detail. Then this basis part testing we'll do today, and control structure testing we'll do today. Okay, driving test cases is not that important, so we'll not do it. So today what all topics we'll be covering is, we'll be covering white box testing, black box testing, then types of white box testing. Okay, okay, these basis part testing, control structure are basically type. either of black box or white box. So today we'll be focusing on types of these two testing, that is white box and black box. If you see, this is what we have done in the previous class. So again, I'm requesting everybody, if you have not watched the video, please do watch it. Okay, part one is important, equally important, as you can get question from anywhere. It was a very important software testing diagram that we have discussed. We have discussed static testing. Yes, today we'll be discussing dynamic testing, that is an equal part. स्टैटिक टेस्टिंग हमने कर रखा है ऑलरेडी. ये आपके टेस्टिंग लेवल्स हैं, यूनिट टेस्ट, इंटीग्रेशन टेस्ट, सिस्टम टेस्ट, एक्सेप्टेंस टेस्ट. So these are very important, as you all know, everyone. Big bang testing, top down testing, bottom up testing, stub, driver. These questions have already been asked in previous exams. As I'm repeating again and again, please do watch this video. So system testing में functionality testing, performance testing, security, portability, acceptance testing में alpha testing, beta testing, and this is the basic of what we have done in the previous class. Unit testing done by developers, integration done by testers, system done by testers, and acceptance done by end users. Today we'll start with functional and non-functional testing. So अगर आपने ये diagram ध्यान से देखा होगा, this one, you can see that in dynamic testing that we'll be doing today, dynamic testing is divided into two parts, functional testing and non-functional testing. So today our main focus will be on these two, that is white box and black box. ठीक है, so white box में भी यहाँ पे आपको दिख रहा है कि बहुत कम topics है, but white box in itself is a very important part. And you can see here that unit testing comes under white box testing. So today we'll be focusing on white box testing more because we have to understand these things, and in next session we'll be discussing on black box testing. Okay, so let's start with first what is your functional and non-functional testing. You can see that functional testing is performed using the functional specification. As from the name only we can think of, here we are talking about the functions, about the functionality, you can say. ठीक है, here we are dealing with the functionality. So it is performed using the functional specification provided by client and verifies the system against functional requirements. Functional testing is executed first. Business requirements are the inputs to functional testing. So basically, how your software will function. Right. If this is your software, ठीक है, if this is your software, so how you will design it, है ना? Design, what will be the design of the software? What will be the functionality of the software? All these things are defined on the basis of all these things are defined on the basis of user requirement. Yeah, the user will tell me ki how I want my software to be. User will tell you ki I want addition of all positive numbers, I want square of all positive numbers, I want square of all negative numbers, I want square of all decimals also. Right. So how this software will function, how what will be the functionality, whether it will have 2 square, well it will perform able to perform it, it will be able to perform minus 2 square, if it will be able to perform 2.5 square. All these things are the functionality of this software is determined by the user requirements. This is what they're saying. Business requirements are inputs to functional testing. Functional testing describes what the product does. So very important. फंक्शनल टेस्टिंग क्या डिस्क्राइब करता है? फंक्शनल टेस्टिंग डिस्क्राइब करता है कि व्हाट योर प्रोडक्ट विल डू. Easy to do manual testing, whereas non-functional testing क्या करता है? It checks the performance, reliability, scalability, and other non-functional aspects of the software system. Non-functional testing should be performed after functional testing. Obviously, अगर आप एक example लेके समझो, if you take an example, you can always say that suppose there is user one. Okay, user one says that I want to build I want suppose he went to company A. Okay, now he told this company A that create a software for me or build a software for me. Okay, create a software, and the requirements are what? The requirements are that the software should be able to do all mathematical scientific software calculator आप बोलो चाहो तो, जैसे कि it should be able to calculate log, it should be able to perform your trigonometry functions, right? Trigonometry में basic trigonometry I'm talking about sine, cos, get tan, ये हो गया आपका. फिर he is saying that it should be able to perform square, है ना? It will be able to perform square root. ठीक है? एंड ऑफ ऑल नंबर्स, दैट इज पॉजिटिव भी नंबर्स होंगे, नेगेटिव भी नंबर्स होंगे और डेसिमल्स भी होंगे, राइट? सो दिस इज व्हाट द यूजर सेड कि आई वांट यू टू क्रिएट अ सॉफ्टवेयर विद दिस रिक्वायरमेंट्स। सो ऑब्वियसली अब आप मुझे एक बात बताओ, वेरी बेसिक सी बात है, ये अब वी हैव व्हाट, वी हैव फंक्शनल टेस्टिंग, ठीक है? So we have two types of testing. First we have functional testing and another one is non-functional testing. Correct? Functional testing क्या करती है? Functional testing tests the functionality of your product. Correct? It tests the it it tells what the product do. Okay, this is the functional testing. What is non-functional testing? It tests the non-functional features, like it tests the performance of the software, है ना? आपका सॉफ्टवेयर कैसे परफॉर्म कर रहा है, व्हाट इज द रिलायबिलिटी, हाउ मच योर सॉफ्टवेयर इज रिलायबल, हाउ मच योर सॉफ्टवेयर इज स्केलेबल, है ना? दीज आर दी नॉन फंक्शनल टेस्टिंग फीचर्स, ठीक है? नाउ इफ यू थिंक योरसेल्फ, फर्स्ट यू हैव टू क्रिएट द सॉफ्टवेयर, है ना? अगर मैं बोलूँ आपसे कि ठीक है, नाउ यूजर वन हैज गॉन एंड नाउ द बॉस ऑफ द कंपनी सेज परफॉर्म फंक्शनल टेस्टिंग ऑन दिस, will you be able to do it? No. Obviously first you should have a software with you, है ना? एक पहले आपके पास एक मॉडल होना चाहिए, सॉफ्टवेयर बोलो या पहले उसको हम मॉडल बोल देते हैं, ठीक है? मतलब आपके पास कुछ होना चाहिए, यू शुड हैव समथिंग इन योर हैंड दैट शुड बी एबल टू परफॉर्म लॉग फंक्शंस, ट्रिग्नोमेट्री, कुछ भी, मतलब मे बी लेट्स से अबाउट लॉग एंड ट्रिग्नोमेट्री ओनली, ठीक है? देन ओनली यू कैन परफॉर्म नॉन फंक्शनल टेस्टिंग। पहले तो आपको एक सॉफ्टवेयर क्रिएट करना पड़ेगा जिसका आप चेक करोगे, जिस पर आप फंक्शनल टेस्टिंग परफॉर्म करोगे कि वेदर योर प्रोडक्ट इज डूइंग ऑल दीज थिंग्स और नॉट, वेदर योर प्रोडक्ट इज परफॉर्मिंग ऑल दीज थिंग्स और नॉट। तो functional testing is what the product do. So functional testing आप पहले first you will do functional testing. That is, first you will create a software and then you will do functional testing कि whether my software is doing all these things or not. And after, once the developer is satisfied कि ठीक है, I have done all these things as told by the user, then the functional testing will come in case. Now फंक्शनल टेस्टिंग आएगी कि अब ये देखा जाएगा कि इज दिस सॉफ्टवेयर इज स्लो एज कम्पेयर टू दी अदर सॉफ्टवेयर, और इज दिस सॉफ्टवेयर रिलायबल और नॉट, वेदर इट इज गिविंग करेक्ट रिजल्ट्स और नॉट। सो फर्स्ट जो आपकी स्टेप होगा, फर्स्ट स्टेप होगा आपका फंक्शनल टेस्टिंग, उसके बाद यू विल बी एबल टू परफॉर्म दी नॉन फंक्शनल टेस्टिंग, ठीक है? दिस इज व्हाट दे आर सेइंग. They are clearly writing that non-functional testing should be performed after functional testing. Performance parameters like speed, scalability are inputs to non-functional testing. Non-functional testing describes how good the product works. Obviously जब आप उसकी performance check कर रहे हो, आप उसकी reliability check कर रहे हो, so obviously you are checking कि how good your product is. And then it is tough to do manual testing. Manual testing मतलब कि manually आप test नहीं कर सकते. Functional testing में तो अगर हम software example लें तो you can give 2, you know a result is 4, you can give minus result is 4. But in functional testing, if you have to check the performance of your, if you speed, so it is not possible to do manually. In that case you have to use some tools for that. ये basic difference है आपका functional and non-functional testing में. Let's see what is functional testing now. Functional testing is a type of software testing that validates the software system against functional. I told you what is validation. Validation is you are ensuring someone. Now you are ensuring whether this software will work or not. Functional testing is a type of software validation only against the functional requirements or specification. So we are ensuring, ठीक है, जो भी perform कर रहा है functional testing, it is he or she is ensuring that the user requirements are met. The purpose of functional test is to test each function of the software application by providing appropriate input, verifying the output against the functional requirement. So that is what I told. Functional test क्या होते हैं, वो check करते हैं कि वो आपके functions हैं, the function of your software is being performed correctly or not. Software is able to perform the required function or not. You can see, identify the test input, that is your test data. जो भी आपका इनपुट आपने दिया है उसको आपको पहले देखना पड़ेगा कि आपको अपने सॉफ्टवेयर में इनपुट क्या देना है, ठीक है? दिस इज व्हाट यू हैव टू आइडेंटिफाई. कंप्यूट द एक्सपेक्टेड आउटकम्स विद द सिलेक्टेड टेस्ट इनपुट वैल्यूज. मतलब अब सपोज दिस इज द एग्जांपल, लेट्स से अगेन आई विल गिव द सेम एग्जांपल. दिस इज योर सॉफ्टवेयर, okay? So first you said कि okay, I'll give the input as 4. So when I give the input as
4, I know that expected
expected output means the output you know that you should receive is 16. If I talk about a square, so the expected outcome that I expect is 16. So then I'll create test cases. Test cases means test case 1, test case 2, test case 3. So this means that here I'm taking different input. So let's say I'm taking 2.5 as input 1, then I'm taking 4.85 as input 2, then taking minus 335 as input 3. Okay, these are your test cases. So what are they saying? Identify the test input. First you have to identify the data कि आपको input क्या करना है. ठीक है, न्यूमेरिकल डेटा इनपुट करोगे या अल्फाबेटिक उसमें ऑर्डर जो भी आपका डेटा है वो आप इनपुट करोगे. ठीक है, न्यूमेरिकल है या स्ट्रिंग है या क्या है. Compute expected outcome with the selected test input values. जो भी आपने input values ली हैं, ठीक है, whatever input you have taken, you have to find the expected outcome. Then execute the test cases. Then you will compare the actual and computed expected result. बहुत बेसिक है, मतलब I don't know whether this is a requirement to explain or not, but again I'll give you an example. So what you will do is, this is your, suppose this is your software. ठीक है, यहाँ पे you are giving the input and यहाँ पे you are getting the output. Okay, now you are told that this is the basic function of a calculator. ये आपका calculator है, ये software. So now you have to, now first you will identify ki what type of input you have to give. So as you come to know that okay, this is a calculator, so this means I have to give numeric data, है ना, numeric data दो गया. Now we'll create test case. So this is test case 1, this is test case 2, let's say this is test case 3, and this is test case 4. Let's say the input over here is 16. ठीक है, यहाँ पे टेस्ट केस 2 हमने लिया, जहाँ पे हम we can take more than one input in one test case. ठीक है, this is not a big deal. Here we are taking 48. Here we are taking 48 नहीं, let's take small values for us because we are doing it manually now. Let's say 25. Then test case 3 में आपने लिया मतलब 1. ठीक है, log नहीं ले रहे हम, 1 लेते हैं खाली for now. और यहाँ पे हमने लिया 0. ठीक है, so what these are my test cases. Now what operations do I have to perform? So I'll write all these things in this over here कि here I'm performing square root, here I'm performing square, here I'm taking log, and here I'm taking sine. Yeah, sine one. अब यहाँ पे what will be the if someone asks me that what will be the expected output. ठीक है, इस केस में expected output क्या होगा? In this case expected output will be, in this case expected output square root will be 4, है ना. In this case expected output will be EO is expected output. Okay, EO is expected output. Here expected output will be 625. What will be the expected output over here? The expected output will be 0. Log 1 with respect to base 10. Okay, I think it's 0 only. एक बार चेक कर लो, आप चेक कर लेना आप लोग, ठीक है, कि log 1 with respect to base 10. Log 1 base 10 is 0 only. Okay, now here the expected outcome is again sine 0 है तो 0. ये हो गया expected output. Now we will check for the actual output. Now what will be the actual output? Actual output will be the output that you have received from this software. So now suppose the input went 16 input आया and the output you received was 4. So you will write over here actual output 4. So again first let's say we will just check for the actual output. So यहाँ पे फिर आपने input दिया 25. You are calculating square. Let's say यहाँ पे आ गया 625. So again you will write actual output 625. Then let's say यहाँ पे आपने input दिया ये log 1 का. ठीक है, now you have to calculate log. Suppose the result came over 0. Actual output क्या आ गया यहाँ पे? Actual output आ गया 0. Correct. Then let's say that यहाँ पे आपने input दिया ये 0. You have to calculate sine and let's say यहाँ पे आ गया 4.5. ठीक है, the actual output here you are getting is 4.5. Now what you will do? Now you will check. So आपने check किए test cases. Actually, you will check these two values. So these are equal, test case 1 passed. These are equal, test case 2 passed. These are equal, test case 3 passed. Now these are not equal. So test case 4 is rejected. So now to confirm yourself, what you will do, test case 4 में आप एक और वैल्यू दोगे. So instead of 0, let's say आपने दिया 1. Okay. Now instead of 0 you gave input 1. So what is the expected value for 0? Sin 1 is 90. Sin 0 is this. This will be sin inverse, not 1. लेट्स से यहाँ पे आपने दिया 90, नॉट 0, सॉरी, यहाँ पे आप दो 90 डिग्री, मतलब sin 90 आप कैलकुलेट कर रहे हो, ठीक है, 90. और एक्सपेक्टेड आउटपुट आपका क्या आना चाहिए, expected output. So what is the value of sin 90? Sin 90 value is 1. So now you're expecting कि 1 आना चाहिए. Let's suppose यहाँ पे अब यहाँ पे previously यहाँ पे आ रहा है 1.5. So again 1 and 1.5 are not equal. This means that your calculator is not able to perform the sign, that is your trigonometry functions are not being able to perform. So this is how you will do your functional testing. वो आपसे यही बोल रहे हैं कि what you will do in functional testing. Functional testing में you will first you have to find the input, what input you have to take, you will calculate the expected output. उसके बाद then you will check for the test cases. And then you will calculate whether your expected output is equal to actual output. अगर वो है, then this means your calculator, your software is working fine. But if any test case fails, this means that your functional testing has failed. Your software is not able to perform the actual requirement. I hope this is clear to everyone. Okay, now we have two type of testing. So basically what we have two names. We have functional testing and we have structural testing. This is also very confusing at times. So everyone has to keep these things in mind. What is functional testing? What is structural testing? In black box testing approach, test cases are designed using only the functional specification of the software. मतलब अब try to understand. Okay? मैंने आप लोगों को बताया था कि I told you that black box में we don't have any knowledge, है ना? If we talk about black box, so I told you that this is not visible to the टेस्टर, है ना. ब्लैक बॉक्स में ये पूरा ब्लैक है, मतलब यहाँ पे क्या है हमें कुछ नहीं पता. वी ओनली नो दैट दिस इज अ कैलकुलेटर. ठीक है, दिस इज व्हाट वी नो कि दिस इज अ कैलकुलेटर एंड व्हेन आई गिव इट 4, इफ आई आस्क इट टू परफॉर्म स्क्वायर इट विल गिव मी 16. If I give it 16 and ask it to take square root, it will give 4. We only know the functionality of it. Functionality मतलब कि we know कि calculator में क्या क्या हमने inputs देंगे तो हमें क्या क्या outputs आ जाएंगे. This is what is written here. In black box testing, test cases are designed using only the functional specification of software, that is without any knowledge of internal structure of software. मतलब they are saying कि if you are talking about calculator, तो आपको नहीं पता कि what coding they have used inside. In case of black box, ठीक है, you only know about the functionality of the calculator. You don't know कि what is the code used inside this. So for this reason, black box testing is known as functional testing. Very, very, very important point. This slide is very important. Okay, so because in functional testing we only know the what will be the functionality of the software, black box testing is known as functional testing. On the other hand, in white box testing, designing test cases required thorough knowledge about the internal structure of software. White box testing is called structural testing. So again, very important. ब्लैक बॉक्स को आप बोलते हो फंक्शनल. आई एम राइटिंग इट अगेन इसलिए जैसे कि ये आपके हाईलाइट्स में रहेगा और आपको याद रहेगा ये. ठीक है, white box is functional testing and black box is functional testing and white box is structural testing. Okay, so this is very, 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 very important because they can ask this question in your match the following as well. Yeah, they can simply write instead of white box black box, they can use the terms function and structure. तो आपको पता होना चाहिए कि कौन सा टर्म किसको रेफर कर रहा है. Okay, so ये हो गया आपका functional testing versus structural testing. Now we'll start with white box testing. What is white box testing? That is also known as structural टेस्टिंग। ये मैं इसलिए लिख रही हूँ जिससे कि आपको याद रहे whenever you will revise with this PDF. PDF I'll give it to you on the Telegram group. ठीक है? Now let's see what is white box. White box testing is a software testing technique in which internal structure, design, and coding of the software are tested to verify flow of input-output and to improve design, usability, and security. So basically, in white box testing, we are having the knowledge of internal structure, design, and coding. We have the entire information about the software. In white box testing, code is visible to testers. Very important point. I'll highlight it over here so that आप revise करो तो याद रहे आपको. Code is visible to testers. Okay, so it is also known as clear box testing, open box testing, transparent box testing, code based testing, glass box testing. So ये सब नाम ऐसे ये आपको याद होने चाहिए, ठीक है? You should know these names. Other than structural testing, it is also known as clear box testing, open box, transparent box, code based, glass box. ठीक है? White box testing involves the testing of software code for the following: internal security holes, कि अगर मतलब internal आपकी कोडिंग में कोई प्रॉब्लम है या कोई सिक्योरिटी पर्पस का कुछ प्रॉब्लम है तो वो आप फाइंड कर सकते हो. ब्रोकन और पुअरली स्ट्रक्चर्ड पाथ, यहाँ पे हम क्या फाइंड करते हैं बेसिकली, वी ट्राई टू वेरीफाई द फ्लो ऑफ इनपुट आउटपुट. मतलब कि व्हाट वी आर डूइंग, बेसिकली ट्राइंग टू फाइंड कि एक सॉफ्टवेयर में जो हमारी इंफॉर्मेशन है, हाउ दिस इंफॉर्मेशन इज फ्लोइंग इन डिफरेंट डिफरेंट पार्ट. अगर हम इनपुट दे रहे हैं यहाँ से, ये आउटपुट हमें यहाँ मिल रहा है, तो हाउ द इंफॉर्मेशन इज फ्लोइंग, व्हाट इज द पाथ दिस इंफॉर्मेशन इज फॉलोइंग. ठीक है? सो ब्रोकन, अगर मान लो इफ देर आर टू वेज, ठीक है, दिस इज द इनपुट वी गेव एंड नाउ देर आर टू वेज टू गेट द आउटपुट. ठीक है? एंड सपोज this path is broken over here. So with the help of white box testing we can find the broken path या फिर poorly structured path. कभी कभी ऐसा भी होता था कि एक पाथ यहाँ से जाके फिर यहाँ की वैल्यू जो है वो बेसिकली यहीं से आके निकलती. So this is a poorly structured path. Okay, so broken or poorly structured paths, flow of specific inputs to the code, expected output, functionality of conditional loops, testing of each statement, object, and function on an individual basis. So basically, in white box testing, we are checking the coding, basically the flow, the code कि आपका सॉफ्टवेयर में आपने जो कोड यूज किया है उसमें इनपुट आउटपुट का फ्लो कैसा है, nothing else. A major white box testing is called code coverage analysis. Code coverage analysis eliminates gaps in a test case suite. It identifies areas of a program that are not exercised by a set of test cases. कभी कभी क्या होता है, what happens is that whenever we have a software with us, ठीक है, sometimes we design test cases but certain time, मतलब बहुत rare भी होता है ऐसा कि certain parts of the code are not touched by these test cases because one is not aware about कि टेस्ट केस मान लो यहाँ पे एडिशन का है, यहाँ पे स्क्वायर रूट है, यहाँ पे लॉग है, इट विल हैपन दैट समटाइम्स एनी ऑफ द फंक्शन गेट्स मिस्ड. कोई टेस्ट केस है जो कवर नहीं कर पाता. सो दैट पार्ट where the tester is not able to find out or tester has missed certain areas, that area of the program is being covered by this code coverage analysis. Once gaps are identified, you create test case to verify untested part of the code, thereby increasing the quality of software product. So for this we have automated tools. Okay, code coverage analysis के लिए we have automated tools to find out कि कोई आपका प्रोग्राम का ऐसा एरिया तो नहीं है जो रह गया हो. In order to find out, in order to identify कि whether there is any area which has been left out or which has not been covered by the test cases. There are numerous coverage types such as condition coverage. I hope you all know what is condition coverage. Condition is where one statement is having three or more than two flows, है ना? मतलब conditions है कि either we can choose condition 1, we can choose part 2, we can choose part 3. This is condition coverage. Multiple condition coverage मतलब हो सकता है कि एक से ज़्यादा nodes हो that are having this condition problem. ठीक है? Path coverage, function coverage, etc. Each technique has its own merits and attempts to test all parts of software code. Using statement and branch coverage. So basically you can see that first let's talk about here. स्टेटमेंट कवरेज है, स्टेट मतलब सारे स्टेटमेंट जो आपके, ठीक है। डिसीजन कवरेज, ब्रांच कवरेज, कंडीशन कवरेज, पाथ कवरेज, कंट्रोल फ्लो टेस्टिंग, डेटा फ्लो टेस्टिंग. These are different types of white boxing techniques. Using statement and branch coverage, you generally attain 80 to 90% code coverage, which is sufficient. So अगर आपके पास, suppose you're not having enough tools, you can also use these two techniques, statement and branch coverage, and इनकी help से भी आप अपने code को 80 to 90% आप cover कर सकते हो. We'll see one by one what is statement coverage. I hope कि यहाँ तक किसी को problem नहीं हो रही होगी, right? यहाँ तक सबको clear हो रहा होगा. Okay, let's see what is statement coverage. In this technique, aim is to traverse all the statement at least once. क्या बोल रहे हैं वो कि suppose this is my program, ठीक है. Let's talk about flow of the program. This is the flow of program, not program, flow of program. Okay, from this node I am going over here, then I'm going to this node, ठीक है. ये आपके different different nodes हैं. Then I'm going to this node, then I'm going to this node, and then I am ending it over here. Again from this node I'm going to this node, then again I'm going to this node, then I'm going to this node, ठीक है, in this node, and then I'm going to this node, and then I am giving the output. Okay, now let's say again there's one more path, we're going from this node, this node, this node, directly to this node and this. What is statement coverage? Let's say these are different nodes, A, B, C, D, E, F, G, H, I. So this is the end. Okay, so what this statement coverage will do, it will make sure that all the statements, okay, all the statements of the code has been traversed at least once. This is one statement path है ना, ये आपने पहला cover किया. Then next क्या हुआ आपका, next suppose आपने ये traverse किया, फिर आपने ये traverse किया, फिर आपने ये traverse किया again, and then आपने ये traverse किया. Okay, then next can be what, next can be you visited this part, then you visited this part, then you visited this part, then you visited this part, and then you visited this part. Yeah, and the last option can be you visited this part, you visited this part, you visited this part, you visited this part, and you reached over here. So you can see that all the statements, okay, all statements have been traversed at least one. So statement coverage says that all the statements have to be covered at least one, have to be traversed at least once. You see what is written. Statement coverage in this technique aim is to traverse all statement at least once. Hence, each line of code is tested. In case of a flow chart, every node must be traversed at least once. Since all lines of code are covered, it helps in pointing out faulty code. Obviously, मतलब जब आप सारे ही path को traverse कर लोगे, तो if there will be any fault in any of the path or any of the statement, you will be able to find that very easily. For example, if you see this, I don't know whether it's visible to you or not. Hmm, visible तो होगा I guess, है ना? Just look at this part, ठीक है? This one. From here it started. Okay, I'll help with the highlighter. From here it started. It reached A. Now from A I have two options. Either I can go to B or I can go to C. So what it did, it chose this path, this statement, A to C. Okay, from C now it has one option only to go this way from C to D. Now G is the ending node. Okay, because all the nodes are incoming. I hope you all know this. I hope you all know that if this is your node, so these are your incoming edges, right? Incoming edges, इसको आप in degree भी बोलते हो, and these are your outgoing edges. ठीक है. अब एक चीज और that you have to keep in mind, if there is a node, okay, this is a node and it only has outgoing edge, okay, मतलब only outgoing edge, it will be your starting node. Okay, and if suppose if there is a node, let's say H, okay, and it only has incoming nodes, okay, only incoming nodes, only incoming edges, sorry, only incoming edges, it will be your ending or stopping node. This will be node, not edge. Okay, this is very important to keep in mind. Why it is important? Because it will help you to remember, it will help you to find कि कौन सी node starting की है, कौन सी node ending की है. Okay, so if you see over here, A is the one having, ये आपका basically यहाँ पे जो है ना, this arrow is simply representing that start from here. ठीक है, this arrow you must be thinking कि now A is not the starting node, no, यहाँ पे कुछ है नहीं, कोई node है नहीं, so basically आप सोच सकते हो यहाँ पे लिखा हुआ है एक start node, ऐसे करके सोच, नथिंग एल्स. ठीक है, यहाँ पे एक नोड है जो बोल रहा है स्टार्ट नोड, मेन नोड आपकी ए है. And you can see this node B, all the nodes are incoming over here, there's no outgoing node, outgoing edge, so this means that G is your ending edge. Okay, so now we have to, what we are doing statement coverage. So basically we have to cover these statements. So we covered these statements A to C and C to G. Okay, now what we will do, now we'll see the another part. Now what they're doing here, they are covering A to B, then they're covering B to D, then D to E, then E to F, and then F to G. This is the second coverage. Okay, so अब आप देखो अगर स्टेटमेंट कवरेज में वो क्या बोल रहे हैं, एवरी नोड मस्ट बी ट्रेवर्स्ड. क्या बोल रहे हैं यहाँ पे क्लियरली लिखा हुआ है एवरी नोड मस्ट बी ट्रेवर्स्ड. यहाँ पे एज की बात नहीं हो रही है. ओके, एवरीवन हैज टू रिमेंबर दिस. इन योर स्टेटमेंट कवरेज दे आर टॉकिंग ओनली अबाउट द नोड. Okay, I'm repeating again myself. In statement coverage, they are only talking about the nodes. In statement coverage, they are saying every node must be traversed at least once. Okay, statements ये आपके, अगर आप देखो, अगर आप समझो इसे from your exam, from your code point of view, let's say that I have, let us define few coding is it छोटी सी, integer A, then I have integer B, then I have let's say A equal to 5, okay, and I say B equal to 6, very basic I'm taking. Then I have defined an integer C, integer C, and I'm saying C is equal to A plus B, and then I'm saying return. Okay, so now what I'll do, let's say that I'll name these lines. Let's say that अब यहाँ पे I'm declaring, so I can write it as A, I can leave them also, but let's say that suppose I am taking that these statements as well. So I'll have A, I'll write it as A, this will be B, this will be C, this will be D, this will be E, this will be F, and this will be G. Now I can say that अब यहाँ पे हमें कुछ भी if statement नहीं आया है ना, हम इसको लिख सकते हैं दैट रिटर्न की जगह थोड़ा बड़ा हो जाएगा प्रोग्राम आपका. काम और करते हैं, चलो कोई नहीं, लेट्स से ठीक है, इफ C इक्वल टू नहीं, इफ C मॉड आएगा, सॉरी मैं जनरल लिख रही हूँ. ठीक है, आप बता C mod 2 इक्वल टू 0, लेट्स इट इज even else odd. Okay, let's say this is the, and then I am saying return. ठीक है, तो आपका ये हो गया F, then आपका ये if हो गया आपका G, then ये आपका एक H, फिर I, फिर J, फिर ये K. तो मैं यहाँ से if I start it is like A, then A के बाद you have to go to B, then B के बाद you have to go to C, then C के बाद you have to go to D, then D के बाद you have to go to E, and E के बाद you have to go to F, then F के बाद you have to go to G. Now with G you have two options, है ना, either you can take even वाला part you can take, or you can take odd वाला part. अगर suppose यहाँ पे इस program में we make certain changes and we have this path as well, let's say for example, ठीक है, just ignore this नाउ लेट्स से कि यहाँ पे हमने फ्लोचार्ट बनाया. नाउ इफ आई एम एबल टू कवर, if I'm able to cover, if I'm able to cover, highlighter is not working on it. Okay, if I'm able to cover this like this, or if I'm able to cover this, matlab somehow I'm covering all the nodes. This means that statement coverage is done. This is what they're saying कि in statement coverage all the nodes have to be traversed. अगर आप देखो ना यहाँ पे भी इस example में भी they have not focused on covering all the edges. ये वाली edge रह गई है, अगर आप देखो ये वाली edge cover नहीं हुई है ना इसमें ये वाली edge, this edge is not covered either in this or in this, but still they have not taken it. Why? Because all the nodes have been traversed, है ना. इसमें भी traversed a c g, इसमें भी traversed a b d e f g. So all the nodes that were present in this program, in this flowchart, have been traversed. This is statement coverage. Every node must be traversed at least once. Clear? Next we have branch coverage. Now in this technique, test cases are designed so that each branch from all decision nodes, each branch from all, I hope you all know what are decision points or decision nodes. These are your decision nodes or decision points जिनसे we have more than one option to go from. Okay, so your A is a decision node है ना. Let's write all the nodes, decision points. ये आपका decision point है. B is your decision point, right? No, C is not there, D भी नहीं है. E आपका decision point है, right? F नहीं है और G भी नहीं है, ठीक है. Now what they are saying in flow chart for if you want to talk about branch coverage, all edges must be traversed at least once. Branch coverage में हमारा focus होता है to traverse all the edges. I hope this point is clear. Statement coverage में your focus is to traverse all the nodes. Branch coverage में your focus is to traverse all the edges. Now we'll zoom in one by one and we'll see. So this is there. From A we went to C, and then from C we went to G. So we have covered this branch. Okay. Then A to B, B to D, D to E, E to F, F to G. Second one done. Now we have A to B, B to G. This part. And then here we have A to B, B to D, D to E, E to G. So as you can see, there are 4 cases. But in the previous case, there were only 2 cases. Why there were only 2 cases? Because in 2 cases only we have traversed all the nodes. But here we have to take 4 cases because we have to traverse all the edges. So remember this point, very, very important. What is the point? The point is that for statement coverage, we have to cover all nodes. ठीक है. And for branch coverage, we have to cover all edges. Okay, so this is the point that you have to keep in mind when you're dealing with nodes, your statement and branch coverage. Okay, ये एग्जाम में पूछा गया इसलिए I'm repeating again and again. Then we have basis path testing. So in this technique, control flow graphs are made from code or flow chart. Okay, मतलब what you're doing, you are given a code. Okay, एक code आपको given है, उससे आपको cyclomatic complexity calculate करनी है. मतलब पहले तो you will get a code जो भी हमने किया, that we were having integer a, we were having integer b, then we named them as a, b, and then we draw them as nodes, and we then saw the flow of the statements. This is what is control flow graph जो हमने create किया. ये आपका कंट्रोल फ्लो ग्राफ है. दिस इज क्रिएटेड विद द हेल्प ऑफ अ कोड. ऑब्वियसली कोई कोड होगा आपके पास, उस कोड को आपने स्टेटमेंट्स को नेम दिए होंगे ए बी सी डी ई, एंड देन यू हैव क्रिएटेड दिस कंट्रोल फ्लो ग्राफ. इन दिस यू आर शोइंग द फ्लो ऑफ कंट्रोल्स कि ए के बाद या तो बी पे जा सकते हो या सी पे जा सकते हो. दिस इज व्हाट इज कंट्रोल फ्लो ग्राफ. Basis path testing क्या है? Basis path testing says in this technique control flow graphs are made from code or flow chart, and then cyclomatic complexity is calculated. I hope cyclomatic complexity हमने सुना होगा, which defines the number of independent path. Very very important, ये आप सबको याद रखना है कि cyclomatic complexity क्यों करते हैं हम. पता है साइक्लोमैटिक कॉम्प्लेक्सिटी क्या है? एवरीबडी नोज कि व्हाट इज साइक्लोमैटिक कॉम्प्लेक्सिटी, हाउ डू वी कैलकुलेट साइक्लोमैटिक कॉम्प्लेक्सिटी, बट नोबडी क्वेश्चंस व्हाई साइक्लोमैटिक कॉम्प्लेक्सिटी. तो साइक्लोमैटिक कॉम्प्लेक्सिटी आपकी ये चीज है ना, और भी जब आप इंटरव्यू ले जाओगे तब भी आपको हेल्प करेंगी. ठीक है. सो व्हाई साइक्लोमैटिक कॉम्प्लेक्सिटी? बिकॉज साइक्लोमैटिक कॉम्प्लेक्सिटी हेल्प्स अस टू कैलकुलेट द नंबर ऑफ इंडिपेंडेंट पाथ so that minimal number of test cases can be designed for each independent path. तो हमें क्या फाइंड करना है? साइक्लोमैटिक, अगर साइक्लोमैटिक कॉम्प्लेक्सिटी की वैल्यू आती है 7, दिस मीन्स दैट इन माय कंट्रोल फ्लो ग्राफ देयर आर 7 पाथ, 7 इंडिपेंडेंट पाथ. 7 इंडिपेंडेंट पाथ मतलब कि नो पाथ इज बीइंग रिपीटेड. अगर ये पाथ बोल रहा है ए बी सी, वो पाथ बोलेगा डी ई ए बी, मतलब कि कोई भी पाथ रिपीट नहीं हो रहा. I hope this is clear to everyone why we are doing cyclomatic complexity. Cyclomatic complexity is done, is calculated in order to find the number of independent paths. क्या steps क्या है इसके? सबसे पहले you have to make the control flow graph from the code. ठीक है, आपको कोड अगर दिया हुआ है, अगर कोड दिया है तो from that you have to make a control flow graph. How you will do? You will name all the statements. Statement 1 को आप बोल दोगे A, statement O, and the nodes will be your statement. ठीक है, अगर मेरे पास कोई एग्जाम्पल होगा सो विल डू इट. देन सेकंड, कैलकुलेट द साइक्लोमैटिक कॉम्प्लेक्सिटी. थर्ड, फाइंड द इंडिपेंडेंट पाथ. अगर साइक्लोमैटिक कॉम्प्लेक्सिटी वैल्यू 4, तो यू हैव टू फाइंड द 4 डिफरेंट पाथ्स कि 4 डिफरेंट पाथ्स हैं क्या. ठीक है. देन यू विल डिजाइन द टेस्ट केसेस अकॉर्डिंग टू द ईच इंडिपेंडेंट पाथ. वेरी सिंपल. अब लेट्स सी के कुछ केसेस भी हैं हमारे पास. सो लेट्स स्टार्ट विद कंट्रोल फ्लो ग्राफ. अभी तक समझ में आ गया होगा. आई होप देयर इज नो प्रॉब्लम. किसी को कोई भी प्रॉब्लम हो, यू कैन राइट योर प्रॉब्लम इन द कमेंट सेक्शन और यू कैन आस्क मी इन द टेलीग्राम ग्रुप. एनीबडी हैज एनी प्रॉब्लम इन एनी ऑफ द पार्ट ऑफ दिस वीडियो. ठीक है. So a control flow graph describes the sequence in which different instructions of a program get executed. I told you कि अगर if there is suppose if वाला statement है तो दो cases आ जाएंगे. So this is how the control is flowing. From this if we can go either to this part or this part. So control flow graph describes the sequence in which different instructions of a program get executed. In other words, control flow describes how the control flows through the program. मतलब कि अगर मैं इस स्टेटमेंट पे हूँ तो उसके बाद आई कैन गो ईदर टू हेयर और आई कैन गो हेयर या आई कैन गो लाइक दिस आल्सो. Okay, so control flow graph basically defines the how your control is flowing throughout the program. In order to draw the control flow graph of a program, all the statements must be numbered first. Very important. मैंने आपको बताया कि जितने भी statements हैं आपके कोड में, ठीक है, all the statements have to be numbered. Numbered से मतलब you can write as 1 2 3 4, you can write A B C D, whatever way you feel like. Okay? The different numbered statement serves as nodes of the control flow graph. I hope this point is clear. An edge from one node to another node exists if execution of statement representing the first node can result in the transfer of control of other node. What they are saying basically, try to understand this point. Mm-hmm. ठीक है. Now what we'll do, we'll number the statement. Let's say I'm naming it as statement number 1, statement number 2, statement number 3, statement number 4, statement number 5, statement number 6, statement number 7, statement number 8, statement number 9, statement number 10. What this is doing, we have initialize A with value 5, initialize B with value 6, we have a variable C is equal to A plus B. Okay, now we'll find the value, we'll have the condition if C is greater than 5, we'll print C, otherwise we'll print A. Okay, now this is your program. Now we'll draw the control flow graph. So how we'll do it? So control flow graph, basically we will have all the controls. So we have node 1. 1 say we are moving to 2. 2 say we are moving to 3. 3 say we are moving to 4. 4 से we are moving to 5. यहाँ तक it's very direct. Obviously आप देखो 1 के बाद आप 2 पे जाओगे ना, ऐसा तो है नहीं कि 1 के बाद सीधा C आ जाए या 1 के बाद सीधा 4 आ जाए. No, this is not possible. We have to see the flow. ठीक है, so ये हमने flow check किया. उसके बाद अब 5 पे we have if statement. So 5 के बाद we have the condition कि either I can go over here or I can go over here. So 5 के बाद I am taking 6. 6 says that if C is greater than 5, then I will print C. Else आपका है statement number 8. अगर ये condition follow नहीं हुई, so I'll go over here 8. Else I'll print 9 and then return. तो यहाँ से भी आप 10 पे आओगे और यहाँ से भी आप 10 पे आओगे. This is your control flow graph. So what you did first, you first numbered all these statements, then you draw the CFG, then you will find second step, you will find the cyclomatic complexity, okay, and then you will find the number of independent paths. So basically there will be I think 2 paths only, है ना? So this is how you will do it. अभी आगे जब हम calculate कर लेंगे तो we'll see next, ठीक है? इसके बाद के steps ये हैं. So I hope this is how you know how we calculate the control flow graph. वो कैसे calculate करोगे? जब हम CFG पढ़ लेंगे तो this will be your homework that you have to calculate the cyclomatic complexity of this program yourself. Let's talk about. I think this is clear to everyone now. ठीक है, अब ये है आपके पास A is equal to 5, B is equal to A multiplied 2 minus 1. But tell me how many nodes will be there and what आप इसको खुद ही ड्रॉ कर लो. ठीक है, खुद ड्रॉ करके ये आपके पास दो कोड्स हैं. पहला कोड है A is equal to 5, B is equal to A multiplied 2 minus 1. Second code है if A is greater than B, C is equal to 3, else C is equal to 5, C is equal to C multiply C. Now you have to draw the control flow graphs. I'm giving you 5 minutes. Draw this control flow graph yourself. या फिर वीडियो को पॉज कर लो and then you can draw it. Yeah. So let's check for the first. I hope आपने pause करके खुद draw किया होगा. If I name it as statement number, this is my statement number 1 and this is my statement number 2. So I'll be representing it as nodes 1 and 2. So this is what you will get. 1 up C. You must be thinking कि 1 के बाद 2 क्यों? Because if you notice in statement number 2, आप B की value derive कर रहे हो from A with the help of A. So obviously पहले आपको A की value define करनी पड़ेगी. This is why we are writing 1 and then we are doing 2. So 1 के बाद we are following the flow is. Again same, we'll name this as statement number 1. This will be your statement number 2. This will be your statement number 3 and this will be your statement number 4. If you see the flow from if we have, ठीक है, if के बाद दो कंडीशन है, या तो C की वैल्यू 3 हुई या C की वैल्यू 5 हुई. So 1 से 2 या 1 से 3. Okay, and then this is there, that is after यहाँ C जो है थोड़ा यहाँ आ जाता है, यहाँ पे है ना, यहाँ आ जाता है C is equal to C multiply C, but it's okay. We understood that this is over from here only, यहाँ तक else तक खत्म हो गया आपका if part. ये वाली जो है आपकी ending वाली part है. So I hope this is clear to everyone, है ना? How you will draw control flow graph is clear. I think there's no doubt in this question. This up till here. Then we have Euclid's GCD computation algorithm. मतलब basically यहाँ पे एक greatest GCD. I hope you all know what is GCD. GCD is greatest common divisor. तो ये क्या है, ये हमारे पास एक प्रोग्राम है, ठीक है. दे हैव गिवन अस अ प्रोग्राम, दे हैव रिटन दिस प्रोग्राम. दिस इज द प्रोग्राम फॉर कैलकुलेटिंग द यूक्लिड्स ग्रेटेस्ट कॉमन डिवाइजर. अब इन्होंने यहाँ पे क्या किया, दे हैव themselves numbered these statements, ठीक है. यहाँ से while से they have started, they have numbered as 1. I'll just zoom in so that clearly visible हो. यहाँ पे आप देख सकते हो कि यहाँ पे they have themselves numbered these statements 1 2 3 4 5 6. You don't have to number them. उन्होंने आपके लिए इसको ऑलरेडी नंबर कर दिया है, ठीक है. यहाँ पे आप सोचो, ये पहले अगर if you would have done it yourself, you would have given this as number 1, but they have ignored this statement, that is int compute GCD integer x integer y. You don't have to take this. They have taken only 1 2 3 4 5 6. That is while x is not equal to y, if x is greater than y, then x equal to x minus y, else y equal to y minus x, then statement number 5 and statement number 6. So now try and draw the control flow graph for this. So as you can see, statement 1 is a while condition, है ना. while में तो अब while को आप लोगे कि नहीं डिसीजन ट्री, डिसीजन नोड की तरह. तो सबसे पहले लेट्स गो विद दिस फ्लो, ठीक है. 1 के बाद क्या है कि while x is not equal to y, if, तो 1 के बाद we went to 2, that is if x is greater than y. जैसे if आया मतलब कि conditions आ गई. So if x is greater than y, then x equal to x minus y, that is statement number 3. else y equal to y minus x. और फिफ्थ पे if आपका क्लोज हो गया, ये आपका if वाला पार्ट था. एंड एट 5 if statement is closed. अब यहाँ पे आप देख लो कि 3 से 1 भी जा रहा है. Why? Because यहाँ पे लिखा है कि while x is not equal to y, जब तक ये while loop चलेगा. So this means that कि यहाँ से आप यहाँ जा रहे हो, अगर ये आपकी कंडीशन ट्रू हो रही है if x is greater than y और आप ये परफॉर्म कर रहे हो, so you have to again go and check for the while condition. So यहाँ से आप वापस आ गए 3 से 1 पे. ठीक है. अब फिफ्थ के बाद क्या है, रिटर्न x. तो फिफ्थ के बाद अब ऑब्वियसली यू मस्ट बी थिंकिंग कि अब फिफ्थ से सिक्स्थ पे क्यों नहीं आया, है ना. ऐसा आप सोच रहे हो कि यहाँ से यहाँ क्यों नहीं आया. ऐसा इसलिए नहीं आया बिकॉज जो वाइल कंडीशन है, अगर मैं मान लो इफ आई एम टेकिंग x इक्वल टू 4 एंड y इक्वल टू 4, कंडीशन क्या है, वाइल x is not equal to 4. अब ये कंडीशन फॉल्स हो गई because 4 is equal to 4. I will not go inside this loop. मैं इस लूप में जाऊंगी ही नहीं, है ना. सीधे I'll move out of this loop. I'll move out of this while loop. इसीलिए 1 से डायरेक्ट 6 का कनेक्शन है, 5 का नहीं है. बिकॉज 5 तो यहाँ पे खत्म हो गया. 5 तो यहाँ पे खत्म हो गया कि y और x में जो भी वो प्रिंट करना चाहे वो करे, यहाँ पे इट्स ओवर. बट अगर योर while स्टेटमेंट इज फॉल्स, आई होप यू अंडरस्टूड दिस पॉइंट. अगर आपका while स्टेटमेंट ही फॉल्स है, you will not move inside the loop, you will not go inside the loop, you will move out of the loop as soon as you will see that while statement is false. तो इसीलिए यहाँ पे 1 से 6 तो है, 1 से 6 डायरेक्ट है, बट 5 to 6 का कोई कनेक्शन नहीं है बिकॉज these are not connected to each other. This return x is related to this while, कि अगर ये while कंडीशन जैसे ही फॉल्स होगी, आप return x करके बाहर आ जाओगे. I hope this is clear to everyone. Right? तो ये समझ में आ गया हाउ द फ्लो इज दिस. तो 1 से 2 आपकी इफ कंडीशन है. अगर x मान लो इफ दिस विल बी 1 से 2, आप कब जाओगे, x इज नॉट इक्वल टू y, तब आप 1 से 2 जाओगे. बट इफ somehow x becomes equal to y, तो आप 1 से डायरेक्टली लूप के while लूप के बाहर जाओगे. दैट इज 1 से you will come directly to 6 and you will return your x value and you will move on because x and y both are equal. return x लिखा है यहाँ पे खाली. This is how you find the greatest common divisor. This is the program for finding the greatest common divisor. ठीक है, अब म्यूटेशन टेस्टिंग है, बट म्यूटेशन टेस्टिंग से पहले आई जस्ट वांट टू स्टार्ट विद दिस साइक्लोमैटिक कॉम्प्लेक्सिटी. तो सबसे पहले तो we'll see what is a linearly independent path. So a linearly independent path is any path through the program that introduces at least one new edge that is not included in any other linearly independent path. तो हम इसका एग्जाम्पल ऐसे ले सकते हैं. Let's say that we have A to B, B to C and C to D. Then we have A to B, B to D, D to E. And let's say we have A to B, B to C, C to D and D to E. मतलब अगर हम इसे draw करें, so we have A, B, C and D. And then we have A to B, then we have B to D, and then we have D to E. Okay. Then we have A to B, B to C, C to D, D to E. Okay. Now can you tell me out of these how many paths are linearly independent path? अगर हमारे पास ये पाथ है, इन तीनों पाथ में से how many paths are linearly independent paths? So what is the definition for linearly independent path? It says that it should add at least one new node. New node add होनी चाहिए आपकी. Yes, if you see over here, A, B, C, D. So this is A, B, C, D. Correct. This is you can say at one. मतलब आप कह सकते हो उसको, ठीक है, एक पाथ है A, B, C, D. A, B, D, E. A, B, D, E. Correct. A, B, C, D, E. This is not a independent path because ये already हम यहाँ पे cover कर चुके हैं, है ना. अब ये जो पाथ है आपका, ये इंडिपेंडेंट लीनियर, तो मतलब इन दो में से कोई एक ही लो, है ना. अगर एक मान लो ये पाथ नहीं होता, ये पाथ नहीं है, then you will consider this as linear independent path. But अगर मेरे पास ये पाथ है already, तो I cannot consider this as a linearly independent path because linearly independent path says it should introduce at least one new edge that is not included in any other linearly independent path. If a path has one new node compared to all other linearly independent paths, then the path is also linearly independent. The path coverage testing does not require coverage of all paths but only coverage of linearly independent path. मतलब अगर आपने linearly independent paths को cover कर लिया है, then you don't have to cover all the path. ठीक है. So why we have taken this? Because when we are finding cyclomatic complexity helps us to find the number of linearly independent path. So I hope this is clear to everyone. Now let's talk about cyclomatic complexity. So McCabe's cyclomatic complexity metric provides a practical way of determining the maximum number of linearly independent paths in a program. अगर if we want to find out कि किसी एक प्रोग्राम में how many linearly independent paths are there, for that we have to find the value of the cyclomatic complexity. So in general we have three paths. Though McCabe's metric does not directly identify linear independent path, it informs the approximation. मतलब कि they tells you अगर मान लो आपकी cyclomatic complexity की value is 7, so this means that approximately there are 7 paths you can consider for independent part. अब let's talk about method 1. आप लोगों को सबको पता है, but still I'm telling this. Cyclomatic complexity V of G. Cyclomatic complexity को हम denote करते हैं V of G से. It can be computed as V of G is equal to E minus N plus 2. E is your number of edges, N is your number of nodes plus 2. Second is an alternative way of finding cyclomatic complexity is from the total number of bounded areas. Bounded area मतलब region. तो अगर मैं बात करूँ bounded areas की, तो अगर मेरा कोई ऐसा है, ठीक है, और फिर यहाँ से मैं ऐसे जा रही हूँ, फिर मैं यहाँ आ गई, and then I'm going to this one, and यहाँ से फिर I'm going like this, and then I'm going like this one. ठीक है. So ये एक bounded region हुआ, मतलब closed region. एक ये closed region हुआ, ठीक है, और एक आपका ये बाहर वाला region जो है, so that is for +1. ठीक है, मतलब आप देखो टोटल नंबर ऑफ बाउंडेड एरियाज प्लस वन, ये वन जो है इट इज फॉर द आउटर रीजन. In the program's control flow graph G, any region enclosed by nodes and edges are can be called as a bounded area. मतलब कोई भी ऐसा region जिसको आपने ऐसे बाउंड कर रखा है, ऐसे करके बाउंड हो रखा है, तो दिस इज योर बाउंडेड रीजन. so total number of bounded areas plus 1. एक हो गया मेथड ये v of g is equal to e minus n plus 2, और एक हो गया v of g is equal to total number of bounded areas plus 1. Method 3 है cyclomatic complexity of a program can also be computed by computing number of decision statements. Again, what are decision statements? That are having more than one outgoing statement. If n is the number of decision statements of a program, then McCabe's metric, that is v of g is equal to n plus 1. Three methods we have. पहला मेथड है आपका, पहला मेथड हो गया v of g is equal to e minus n plus 2. सेकेंड मेथड हो गया v of g is equal to bounded areas plus 1. एंड थर्ड मेथड हो गया v of g is equal to decision nodes, स्पेलिंग गलत हो गई, प्लस 1. तो इन तीनों ही मेथड से अप्रोक्सीमेटली सेम ही आंसर आता है, आप किसी को भी यूज कर सकते हो. ओके, सो आई गिव यू वन क्वेश्चन, आप उस क्वेश्चन को ट्राई करो, विल डिस्कस दैट क्वेश्चन, ठीक है. जस्ट गिव मी अ सेकंड. एंड वी हैव टू ट्राई फ्रॉम ऑल द थ्री मेथड्स, जितने भी तीनों मेथड्स हमने पढ़े हैं सभी से आपको ट्राई करना है, ठीक है. सो दिस इज योर नोड 1, node 2, node 3, node 4, node 5, node 6, and node 7. So calculate, I'll write the question, calculate cyclomatic complexity with all methods and write the linear independent paths. ये आपका क्वेश्चन है. Now you have to calculate the method. You have to calculate the values by the given method. So I'll give you few time, few minutes I'll give you. इसको जल्दी से करके आप मुझे बता सकते हो. Method 1, method 2, method 3, and then we'll see कि कितने independent paths हैं. So पहला method that we'll be using is v of g is equal to e minus n plus 2. The number of edges 1, 2, 3, 4, 5, 6, 7, 8. This is one edge. Okay, ये पूरी एक ही edge है. So e की value कितनी हो गई? 8. What is the value of n? 7. 7 nodes. So we'll get what? E is 8 minus 7 plus 2, that is 3. यहाँ से साइक्लोमैटिक कॉम्प्लेक्सिटी आई फ्रॉम मेथड 1 is 3. Let's try for method 2, that is bounded areas plus 1. So you can see that this is your one bounded region, this is your another bounded region. Yes, so we have how many bounded regions? Two bounded regions plus 1, that is again 3. Then we have the third method, that is B of G is equal to decision nodes, or we can say it as predicate nodes as well. I hope you all know decision nodes को हम predicate nodes भी बोलते हैं. So decision nodes मतलब having two outgoing edges. So 3 is the one, ये आपकी एक ये हुई और एक ये हुई है ना. So 3 is your first decision node. Then fourth ये 1 and ये 2. So 4 is your another decision node. We have only two decision nodes. So 2 plus 1 again 3. With all the three methods, we are having the same cyclomatic complexity. So let's write the name of the longest independent or linear independent paths. So one is 1, 2, 3, 5, 6 and 7. ये आपका पहला पाथ हो गया, राइट. दूसरा पाथ हो गया 1, 2, 3, 4, 5, 6 and 7 है ना. 1, 2, 3, 4, 5, 6 and 7. फिर एक जो पाथ आपका और बच रहा है, दैट इज 1, 2, 3, 4, 6 and 7. These are your three independent paths. One is this one straight 1, 2, 3, 5, 1, 2, 3, 5, 6, 7. Then one is 1, 2, 3, 4, 5, 6, 7. And one is 1, 2, 3, 4, 6, 7. This is your numerical for the cyclomatic complexity. This is how you will calculate cyclomatic complexity. So, आपको क्या करना है? You have to find the questions related to cyclomatic complexity and you have to solve them. PYQs भी बहुत सारे हैं cyclomatic complexity के, so वो आप find करके आराम से कर सकते हो. ठीक है, so I'll write it over here यहाँ पे because थोड़ा मुझे याद आ गया. Decision nodes are also known as predicate nodes. Okay, now let's talk about mutation testing. So in mutation testing, the software is first tested by using an initial test suite built from different white box testing strategies. सबसे पहले क्या करते हैं? सबसे पहले एक initial test case बनाते हैं based on the with the help of white box testing strategies. उसके बाद when your initial testing is completed, then mutation testing is taken up. Now what is the idea behind mutation testing? The idea behind mutation testing is, I'll just highlight this one. Idea behind mutation testing is to make few arbitrary changes to a program one at a time. मतलब अब क्या हम कर रहे हैं? पहले हमने क्या किया? जो ओरिजिनल प्रोग्राम था, ठीक है, the original program that was there, what we did, we tested that program. Okay, after testing that particular program, now we started making few changes into the program. Each time the program is changed, it is called mutated program and the change effect is known as a mutant. So suppose मतलब initially क्या था कि initially जो मेरा program था, it was int a is equal to 5 and then int b equal to 6 and then so on. Now mutant जब हमने change किया, mutant में मैंने क्या किया, mutant 1 में I changed a is equal to 15. Then in mutant 2, what I did in mutant 2, I changed value of b is equal to 20. So this is how you will change the values of your program. A mutated program is tested against the full test suite. जो आपका यहाँ पे जो suppose यहाँ पे आपने टेस्ट किया और वैल्यू आई a, अब आप दोबारा से mutated program को टेस्ट करोगे. If there exists at least one test case in the test suite for which mutant gives an incorrect result, then mutant is said to be dead. मतलब अगर ये एडिशन का प्रोग्राम है, यहाँ पे आया 11 है, मतलब कि इनिशियली मेरा जो टेस्ट सूट है अगर मैं ऐड करूँ तो 11 आ रहा है, सपोज यहाँ पे बी की वैल्यू 6 है बट मेरा आंसर अभी भी 11 आ रहा है, तो ये म्यूटेंट यहीं डेड हो जाएगा। मैं एक बहुत बेसिक, दिस इज व्हाट आई एम टेकिंग अ वेरी बेसिक एग्जांपल, ठीक है, कि if I'm making changes and if the mutant is giving wrong answer, ठीक है, if the mutant is giving the wrong output as compared to the initial one, then we kill that mutant, that is we delete that mutant. If a mutant remains alive even after all the test cases have been exhausted, the test data is enhanced to kill the mutant. मतलब अगर after we have in the test cases and then again we are not able to find the fault, मतलब mutant is giving the right answer every time it is being executed, then we enhance our test case, मतलब हम अपने टेस्ट डेटा को थोड़ा increase कर देते हैं, मतलब we change the level of our test date because our motive is to kill the mutant. The process of generation and killing of mutants can be automated by defining a set of primitive changes that can be applied to a program. These primitive changes can be alterations such as changing an arithmetic operator, changing the value of a constant, changing a data type. A major disadvantage of mutation-based testing approach is that it is computationally very expensive since a large number of possible mutants can be generated. आपसे एक क्वेश्चन आया था कि fault based technique is, तो जो वो क्वेश्चन था आपका यूजीसी 2022 का ही, उसका आंसर था म्यूटेशन टेस्टिंग। बिकॉज इफ यू सी नाउ, अगर आप देखो म्यूटेशन टेस्टिंग में, सो वी आर जनरेटिंग different types of mutants, है ना, and with our aim with those mutants is that we are basically trying to find the fault in our program, कि अगर if, क्योंकि 5 and 6 were 11. Again, 15, 6 was also 11. This means that since the mutant has generated a wrong answer, this means that there is error in some code. Then we again will check the full suit, है ना? We'll check the full program. So we are generating and killing the mutant so that we can see that what fault is there in the program, and if there's any fault, what all changes can be made into the program. So this is your mutation testing. So we have a mutated program and then we name them as mutant. ये हम ऑलरेडी कर चुके हैं। सो ये आपका न्यूमेरिकल, ये आपकी ब्लैक बॉक्स है, तो ब्लैक बॉक्स we'll have a video or we'll have a class on black box tomorrow. If I come to the syllabus, agar we'll see what we have covered till now. We have done white box testing today, yes, then we did basis path testing, then we did today control structure testing, that is control flow basically, है ना। Yeah, एक मिनट, just let me see in your black box testing, but the control structure is different. We are confusing it with equivalence, boundary value analysis, cause effect, smoke and sanity, regression, performance. Okay, yeah. So control structure भी हम कर चुके हैं. This is what we have done today. Control structure testing भी हो गया. Deriving test case will not do. Alpha, beta, regression and performance testing and lab. This we'll do in the next class. Okay, so this is what we have done. So we'll quickly discuss कि हमने क्या क्या कर लिया. So if we talk about, so we have done we could discuss today functional versus non-functional. Basic हमने इसका difference देख लिया, yes. Then we saw that okay, functional का the name is functional or black box. And then we saw white box or structural, right? इनका भी हमने difference देख लिया. Then we saw different types of white box testing. So we saw what? First we saw statement coverage. So statement coverage deals with nodes. All nodes have to be traversed at least once. Then we saw branch coverage. Branch coverage is basically with edges, respected to edges. Then we saw basis path testing. In basis part testing we saw the work of cyclomatic, that is your control flow. उसको हम कंट्रोल फ्लो ग्राफ लिखते हैं, सो दैट कंफ्यूजन नहीं होगा. कंट्रोल फ्लो ग्राफ की हेल्प से वी कैन कैलकुलेट cyclomatic complexity. Yeah. And then उसके बाद after types of white box what we did, we did a numerical on finding the computation cyclomatic complexity, that is we have three different methods. And then cyclomatic complexity से हम क्यों करते हैं, to find out the linear independent path. And then उसके बाद we did mutation technique, mutation test. Basically this is what we have done today, and this will help us in doing the basic questions that can come related to software testing if we talk with respect to white box or cyclomatic complexity. So that's it for today. Okay, thank you everyone for watching the session, and if you have any doubt, please feel free to ask me on Telegram. And if you have any doubt related to course, call on the numbers as mentioned. And part 1 is equally important, so if you have not seen part 1, please watch part 1. I'll be sharing the link in the description. Thank you everyone. Take care. Bye bye. Good night.